Hi everybody, this is Squidly Diddly, and here's board problem 41. In a large population of college students, 20% of students have experienced feeling math anxiety. If you take a random sample of 10 students from this population, the probability that exactly 2 students have experienced math anxiety is, okay, well that's where you use your formula in your calculator right here. It said exactly 2. It didn't say 2 or less than, so it's exactly 2. So that's where you do your binomial PDF. 10 students, probability is 0.2, and you're doing 2, and you get that one right there. So choice A. Alrighty? Okay, so this is section 8.1-3, binomial formulas, means and standard deviations, and normal approximation for the binomial distribution. Okay, here we go, binomial probability. All right, and your book is going to show you a very long way. I'm going to remind you of a very short way in just a bit. So the X has the binomial distribution with n observations and probability of p successes on each observation. Remember, binomial distribution is two choices, on or off, left or right, heads or tails, you know, two choices. And you have a distinct number of observations, and each probability is the same, and they're independent of each other. Those are all the characteristics of binomial probabilities. So if k is any one of those x values, you know, any one of them, 0, 1, 2, all the way up to whatever, then the probability that x equals k is, it's just a formula, and this is different from the book. The book's really sucks on this, you guys, is this. And then this formula right here, this n choose k, remember this in Algebra 2, you guys? It was n factorial over k factorial and then n minus k factorial. All right? So, don't get too upset, you guys. It's just a formula. You can plug them in. You get them all in your notes, okay? And NCR is also found in your calculator. I'm not going to use that feature because I haven't looked for it yet, but it's in your calculator in the math part under probability, okay? All right, so we're going to go back to blood types. This is example 8-9 on page 446. Each child born to a particular set of parents has a probability of 0.25 of having blood type O. If these parents have 5 children, what's the probability that exactly 2 of them will have blood type O? Okay, so the count of children with type O blood is a binomial random variable with n equals 5, and probability is 0.25 successes. So we want to find p of x equals 2. So using their formula that they give us, actually this is a different formula from what the book is. The book's is kind of nasty, you guys. I'll show you in just a little bit. Okay, so here it is. I'm going to do n choose k, so I'm doing 5 choose 2. Okay, the probability is 0.25, and then 1 minus 0.25 is 0.75. That's where that came from. Okay, and then k is 2, and this is 5 minus 2, which is 3. Okay, and then I'm going to do a little math over here. The n choose k is 5 choose 3, and then when I do that, it's 5 times 4 times 3 times 2 times 1. Here's 2 factorial, here's 3 factorial. Okay, I'm going to show you that those guys are 3, 2, 1 are the same as just 3 factorials, you guys. So I always stop at the bigger factorial, all right, because they just cancel each other out. And so that equals 10 right there, and you can't see it, but it says underneath there equals 10 because you get 5 times 4 is 20 over 2. So 20 over 2 is 10. So when I plug in 10 right there and 0.25 to the second, 0.75 to the third, you should get 0.2637. Okay? Never fear, your calculator is here. Remember, that's the long way the book is showing you. Don't forget about yesterday's lesson, you guys. When n equals 5, p equals 2, and you want to find out what's the probability of x equals 2, just like your board problem, you do binomial PDF, and it gets you the same thing. Okay? I choose that way over the book's way any day. All right, so here's more on defective switches. This is example 810 on pages 448 and 49. So the number of X switches that fail inspection in example 8.3 has approximately a binomial distribution with n equals 10 and p equals 1. The probability that no more than one switch fails is this. No more than one is less than or equal to 1. So we punch in I'm going to do binomial CDF on this one, you guys, at 1 right there, okay? CDF means you add them all up. You can do binomial PDF of 1 and binomial PDF of 0, get you the same thing, or CDF just adds them all up right there, and you get about almost 74% of the time. Okay, that no more than one of the switches fails out of a group of 10 that you select out of that. Okay, all right, so look, here's the books. You don't have to write this down. This is the book's mess. Look at that. That's how they solved it. Ugh, gross. Okay, all right, so the mean mu and standard deviation sigma of a binomial random variable is this, you guys. Okay, the mean is just the number times your probability, and your standard deviation. This is just a formula right here you guys can use. So the number times the probability times 1 minus the probability. All right, so those darn bad switches. So recall, n equals 10 and p equals 1. All right, so the mean, you guys, is going to be 10 times 0.1, and standard deviation, whoops, there should be a square root right there. Sorry, I didn't put that in there. Let me do that real quick. There's a square root, right? I probably don't have the right color. Rats. All right, so there's a square root right there. Okay, groovy. Yep, there we go. Okay, so as the number n gets increasingly large, your binomial distribution will get closer to a normal distribution. So when your sizes that you're picking are getting bigger, so instead of having n equals 10, say I did n equals 100, it would start getting more and more close to a normal curve. Okay, so shopping attitudes. Here's another example, 812 on page 452 and 53. Okay, are attitudes towards shopping changing? Shopping is gross, if you ask me. Sample surveys show that fewer people enjoy shopping than in the past. That would be me. A recent survey asked a nationwide random sample of 2,500 adults if they agreed or disagreed, so there's your binomial, agree or disagree, that I like buying new clothes. But shopping is often frustrating and time-consuming. Yes, sirree. The population that the poll wants to draw a conclusion about is all U.S. residents age 18 or over. So suppose that in fact 60% of all adults residents would say agree that when they ask the same question. So what's the probability that 15, 20 or more of the sample agree, okay, of the 25? So suppose that 60% of all U.S. residents agree. So what would our probability be that this many or more agree, okay? So I'm going to remind you of some old school math that we did a while ago. Okay, so here's the mean right here, 2,500 times 0.6. So the mean is 1,500. Okay, so the standard deviation, just plug that in, you get 24.49. Okay, so here we are. We want the probability that it's greater than or equal to 1520. So here's our old school math, you guys. Okay, so we're going to plug in 1520 minus the mean divided by the standard deviation. This right here is just your z stuff. You can just pretend like that's z right there, and we calculate this, crank that out right there, so I get z is greater than 0.82. Okay, so remember 0.82, the book always gives you to the left, okay, and we want the right because it's greater than. So the book gives me that right there, so to the right is going to be 1 minus that action right there, so 0.2061. Okay, that would be the probability right there. Okay, the exact answer that we'll learn later how to do is 0.2131. Speaking of later, here's later. Use your graphing calculator to verify this exact answer. Okay, we're going to use the complement rule, you guys. If it's greater than or equal to 1520, then by the complement rule, it's going to be 1 minus the probability that it's less than or equal to 1519. Okay, and we can calculate that in our calculator by doing the binomial cumulative distribution. 2,500, there's the probability, there's 1519, okay, and that gives me the decimal right there. Boom, right there, there's the final answer right there, and that's what we got. Okay, and then the rule of thumb, it's going to ask you on one of them, what's the rule of thumb for a normal approximation for a binomial distribution? It is this, that if your NP is greater than or equal to 10, then you use this normal distribution right here, NP and the square root of NP times 1 minus P. Okay? All right, that's it.